In this video, let's discuss about charge. Let's begin with the definition of charge. Charge is the property of matter which causes it to experience force when placed in electromagnetic field. Now here comes the crucial part. It is a property of a matter, so there can be no charge in free space. Let's move on to the units of charge. In SI units, the units of charge is given by coulombs. It is abbreviated as C. There are other units as well, such as the Gaussian units, in which charge is expressed in fractional units of mass, length, and time. As an exercise, you can find these units. This is the Gaussian version of Coulomb's law. You can use dimensional analysis to find out the unit of charge in Gaussian. Let's move on. The conservation of charge. The total charge in our universe is conserved. You cannot create charge nor destroy it. Also, charge cannot disappear from one place and appear in another. Charge should move through a continuous path. And the differential form of continuity equation guarantees us this. As you can see, the J is the flux associated with the charge, rho is the charge density, and as you can see on the right hand side, which is 0, it ensures that there is no sink or source. If there was a sink or source, then this quantity over here on the right hand side would not have been 0. Now let's move on to electrons and holes. So we know that electron is a fundamental unit of charge, 1.6 into 10 to the power 19 coulombs. Electrons and protons are the most fundamental charge particles that we come across while studying physics. Now, charge is quantized. Metallic conductors, electrons are the charge carriers during conduction process. But in semiconductors, we have another type of charge carrier known as an electron hole, or simply as an hole. The hole is basically a vacancy of an electron. It's a free space. It is not a particle. It is a quasi-particle of essence. Though it's not a particle, we are associating it with some properties of matter, such as charge and effective mass. Now, the hole does not have any charge. Actually, an atom is electrically neutral. The positives and negative charges cancel out. But when there is a vacancy of an electron in an atom, then the entire charge configuration of an atom is equivalent to there being a plus positive E at that point where there is no electron. Right? So as you can see in this figure, this entire configuration of charges is equivalent to a plus E over here. Note that from the definition of charge, there is actually no charge over here. But for our convenience, we are associating with this vacancy a positive plus E. This entire charge configuration is equivalent to a plus E, a positive charge plus E.